Good morning, class. I hope you are having a great day. I would like to talk about Chapter 5, Forces in Two Dimensions, and I would like to do a little bit of review about describing vectors and adding vectors graphically. So, what we're going to do is we're going to start out with the worksheet that I loaded on your Canvas account. The first worksheet is describing vectors. Now, remember that a vector is both magnitude and direction. And so when we start to describe vectors, we must include the direction. And so, for example, we have example 1 and example 2 at the top of your page. We have a graph here, and we have our 4 cardinal directions, and we have a magnitude of 5 meters. We have a distance of 5 meters, but they're also giving us the direction of 30 degrees. And we always want to reference the x-axis, so we're always going to be using what's called a reference angle. So a reference angle is an angle that always references the closest x-axis. So it doesn't matter where the end of the angle is, or you can say that's the terminal side of the angle. Wherever the terminal side of the angle is, the closest degree measure to the x-axis is your reference angle. So in our first example here, we are already given a reference angle of 30 degrees. So since we're always going to reference the x-axis, we can describe this vector as 5 meters at 30 degrees south of east. So whenever we describe our vector, since we're always referencing the x-axis, we're going to say east or west last. We're going to say north or south first. Okay, so let's do a few examples here. So in example number 2, that's in the upper right hand corner of your page, we have a magnitude of 5 meters, but look at this, we're given a direction 30 degrees, but we have to ask ourselves, is this the reference angle? Well, the answer is no, because we are referencing the y-axis, and we never do that. We always have to reference the x-axis. So we know the angle measure between south and east is 90 degrees. Okay, so 90 minus 30 degrees, this is going to give us a reference angle of 60 degrees. So now that we have our reference angle, we can describe this vector. It's going to be 5 meters at 60 degrees south of east. Okay? All right, let's move on to number 1 on the assignment. So we have a magnitude of 11 meters, and then we have a direction of 49 degrees, and this is not a reference angle. So if we were to describe it like this, we would say 11 meters west of north, but we are not referencing the x-axis, so we will never do that. We must use the reference angle. So right here, our reference angle is going to be 41 degrees. This is our angle with respect to the x-axis. So this is going to give me, when I describe this vector, 11 meters at 41 degrees north of west. Okay? Now let's move on to number 2, right here. So we are given a magnitude, and we're given a direction, 25 degrees, and it is south of west. So we have to ask ourselves, are they giving us the reference angle? Well, the answer is yes. So we're going to say this is 7 meters south of west. Sorry, 7 meters at 25 degrees south of west. On number 3, right here, They have given us the reference angle already. So this is going to be 12 meters at 65 degrees north of east. Okay? On number 4, right here, we have a magnitude of 25 meters and we have an angle of 70 degrees. But we have to ask ourselves, is this the reference angle? It is not, because right here it's referencing the y-axis. So we cannot do that. Right here we know that this angle is 20 degrees. So whenever we describe this vector, it's going to be 25 meters at 20 degrees south of east. Okay, so hopefully that will help you get started on describing vectors. On the next worksheet, we have adding vectors graphically. And so what we're going to be doing is using the head-to-tail method. And so what we have here, we have 4 vectors that are provided for us at the top of the page, and they're U, V, S, and T. And so what I want to remind you about the vector is the tail right here is the starting point of the vector, and the head is the end point of the vector. And since we're using the head-to-tail method, we're going to place the tail of the second vector directly on the head of the first vector. And so in number 1, we have vector u plus vector t. So what we're going to do, I'm going to start here, vector u. There's the tail of vector 1. And what let's do is let's label each vector. So I have u, and then vector t. So we're going to place the tail of vector t on the head of vector u. Okay? And so it wants us to draw our resultant. So our resultant is the sum of both vectors, in this case vector u and vector t. And the resultant begins at the tail of the first vector and ends at the head of the last vector. So what we have here is our resultant, and our resultant is the sum of both vectors. It's u plus t. So on number 2, we have vector u plus vector s, right here, vector v. So we have vector v here. Remember, you need to label each one of your vectors. Vector s, using the head-to-tail method. And remember that the resultant is going to start at the tail of the first vector and end on the head of the last vector. So our resultant, v plus s. On number 3, we have s plus t. Okay? So we have vector s. And I think it will help if you always draw both the tail and the arrowhead, the head of each vector, so you know where the vector begins and where it ends. So vector t, we're going to place the tail of vector t on the head of vector s. And our resultant begins at the tail of the first vector and ends at the head of the last vector. So my resultant is s plus t. On number 4, we have vector u plus vector v. So vector u, and then vector v, so using the head-to-tail method. I'm going to draw this just to the side here so it's easier to see. But my tail of vector v is starting on the head of vector u. So I'll do this. Maybe that will make it a little bit more clear. and that is vector v. Now remember that the resultant vector is going to begin at the tail of the first vector and end at the head of the second vector. So, there we go. Remember to draw your arrowhead, and this is going to be vector u plus vector v. I'll do one more, number 5. Right here, we have s plus s. There's vector s. And then head to tail method. Okay. And the resultant, so the sum of the vectors, I'll just draw it below there. Is s plus s. So I hope this helps you get started on both of the worksheets. And if you have any questions, please give me a call or send me an email. I hope you have a great day.